Hello, am I audible? Good evening, everyone. I'm Mithun. I work with PayPal, so I've been working with PayPal close to a year now. I basically work as a senior backend developer, mostly working in Java. But Node is something that I sort of started exploring a couple of years back. So I'm not a pro in Node because my main area of focus is Java, but it's something that has interested me for some time now. So I thought this is a good opportunity to share my understanding about Node. So we'll not be digging deep into what Node is and all that, but my primary area of focus would be EventLoop. How EventLoop works, because EventLoop is what is actually the heart of Node. So we'll initially start try and understand what EventLoop is, then we'll switch to how EventLoop works in Node, so on and so forth. So this is going to be the agenda for today. We'll try and understand what event loop is, multi-threading versus event loop, how event loop sort of sits in Node, parallelism versus concurrency, and finally we'll take some questions. So before we begin, can you just raise your hands for people who have actually worked in Node? Right. So this is going to be interesting for people who are just starting to begin to do Node or JavaScript to get some insight into what event loop is, because I'm sure this is one word which we sort of keep hearing every day, but we'll sort of try and dig deep into it to understand what exactly it is. So this is also sort of we'll go along a journey like where I sort of try to understand how things work, what event loop is, and so on and so forth. So what is JavaScript to begin with? I sort of kept reading about it, and I always so I'm a single-threaded, not blocking asynchronous concurrent language. And it also goes on and says I have a call stack, an event loop, a callback queue, some other APIs and stuff. Too many things at one time, right? So we all know like Chrome browser is built on top of V8 Chrome engine. So I sort of tried and dig into what V8 is. I sort of ripped apart the code of V8 and I sort of checked with V8. Hey V8, do you have a call stack, an event loop, a callback queue, some other APIs and stuff? Let's say I only have a call stack and a heap. I don't know what other things are. Interesting. So this is basically how a V8 sort of architecture looks like. We have on one side the heap where the actual memory allocation happens, the objects and so on and so forth over the execution of the program. On the other side, we have the stack. So stack is basically a data structure where we basically store a sequence of instruction that is getting executed in the program. So there are some other stuff also, something called web APIs, which I never knew of initially when I was sort of trying understanding what it is. So it sort of turned out as a surprise to me that something which we sort of use very commonly in JavaScript, which is set timeout, is not something that is there in V8. It is something that comes with web APIs, so it's not something which is part of V8. It is something external to it, and we'll try and understand how it all sort of sits together and how event loop works. So to begin with, we'll take a simple example, the call stack. How does the flow of a simple program work in JavaScript? So it's a very simple program. We have this multiply function where it takes two variables and returns a multiplication. We have a calc square which calls the multiply function, and we have the print square which calculates the value of calc square and prints it. So to begin with, we have the main function, which is basically the beginning of execution of file access. So as soon as the execution begins, we have the main method. It then calls the print square. It then calls the calc square, which multiplies the number and returns. And finally, we have the multiply method as is. So once we reach there, it sort of returns the function, which is b into b, and that's out of the stack. Then the calc square, which again gets executed and comes out of the stack. Then we have the print square, which calculates the result and prints it. It calls console.log again. And finally, we have the print square in the main, and the call stack gets emptied. Now we have something like this. So So where we actually have a function one which throws an exception, but it is something which gets called from 2, from 3, then finally, so when the execution begins, we have something like this. If you've tried something like this in Chrome, we'll get an exception, which basically shows you the stack trace. So stack trace basically shows you what is there in the stack at that given point in time. So just like the previous example, when finally the execution reaches function 1, it actually throws an exception, and it along with the exception gives you the stack trace which has what is there in the stack at that point in time. So you can see 1, 2, 3, which is basically what is there in the stack trace at that point in time. Now this is also something interesting. So we have a function foo which again returns function foo. It sort of keeps calling itself over and over again. And what happens is the stack sort of gets called by foo over and over again, finally until where we actually get the prompt says, okay, we called this 16,000 times, and finally we get this maximum call stack, the exceeded error. Now, whatever we tried right now, all these 3-4 programs, were actually single-threaded execution. It's a function calls the other function and it executes, and finally we get the result, right? So this is something which is not blocking. But what exactly is blocking? So what happens when things actually become slow? So to give you some sort of example as to what kind of things fall in the category of blocking, is like when you make network requests, when you do image processing, something which is something which is time consuming, say database queries and so on and so forth, fall under blocking, which is because it sort of takes time to execute and give you back the results. But if you look at console.log, it's something which is not slow, it's quite quick. So let me give you an example here on this. So we have var a equal to get synchronous a. So this is basically sort of stub. So we're going to assume that the first call is actually going to make HTTP request to some server to get the response. So it is blocking in that sense. It takes some time to execute, and at that point in time, the stack is actually, the execution is blocked. Nothing is being executed in JavaScript. So we wait for the result. In the second line, again the same thing happens. The flow is blocked, and the third line again we keep blocking. At that point in time, nothing is being executed in by JavaScript at that point. And finally, we sort of print the result. Now, why is this problem? Because we run the code in browsers. So if you've tried as an experiment in browsers, when you actually do such kind of thing, the browser gets blocked. You try to click something, the browser doesn't sort of respond to it because it's actually trying to do something, and so the stack is actually blocked at that point in time. No sort of other execution will happen at that point in time. So what is the solution to that? I mean, when something is blocked, you're actually wasting your time. I mean, there could be a I/O operation which is happening, but why do you want your execution to be blocked at that point in time? You rather have something else done along the line, right? So what is the solution for that? We have asynchronous callbacks for that. And how does it work? So for example, if you look at this simple program, we have console.log key, and then we have a set timer function. Set timer function in simple sense is nothing but a function which does something after a specific interval. And finally, we have a console.log. So if you look at the output, what happens here is we have me printed first, and then we have Geek night printed first, and then after an interval of 5 seconds, we have there printed. How does it really work? So if you look at the call stack, we have the main method again. He gets printed. Again, the set timeout disappears. It comes down to Geek night. It prints Geek night. Finally, after a few seconds, there's a callback to console.log there. Cool. So how does it work? I mean, it works using EventLoop. That is what we actually trying to explore. So I was partially lying to you when I said that browsers can only do one thing at a time, because we have the concept of EventLoop. It's just partially true, because when something sort of blocking comes into picture, it sort of puts this into an event queue, and it tries and execute the other stuff which are sort of not blocking. So in the same example, we'll see what really happens when we run the code again. So we have this key printed. Then we have the set timeout function, and as soon as this is called, uh, it sort of sets a timer and moves it away to an event queue. So we have web APIs here. In the case of Node, we will have a C++ library which is FlipUV. We'll come to that eventually. And it comes here, and there's a timer which is set. The stack is cleared. Now it comes on the second, the last line, prints console.log, clears it, and by that time, the timer is done. It comes back to a calling queue, callback queue, and finally, once it makes sure that the stack is empty, it pushes the callback result to the stack again, prints the output, and completes the execution. Now, what does EventLoop do? So as we saw in the previous example, it watches the call stack and the call queue. So when the stack is empty, it takes the first element of the callback queue and pushes into the stack. This is basically what the whole, on a high level, how EventLoop works. For all sorts of blocking stuff, this is exactly what happens. So this is a very basic example that we showed here. So I'll just run it again. So when, as soon as the execution comes to set timeout, it moves it to a queue. The timer is on. It continues with the execution. It doesn't really wait. And once the timer is out, it is pushed. The result is pushed to the callback queue. We have the stack cleared, and once the stack is cleared, the event loop pushes the first output of the callback queue to the stack. It gets executed, which is printing string there, and finally we have the execution completed. Now, besides set timeout, there are other web APIs, for example, DOM manipulation, calling the HTTP, the XHR, HTTP request, the AJAX call, which are sort of blocking IOs. Now, we also have one more example, which is when we actually set timeout 0 for a callback, what really happens? And I'll explain why we are doing this. One thing to be noted here is like as soon as it's finished printing high and it comes back to set timeout, it moves this to timer queue. The timer is on. It prints Geek night and again pushes that back to the callback queue. Event loop picks it up. The stack is cleared and the callback is executed. There is printed and the execution is complete. So one thing to be noted here is set timeout. We specify an interval in set timeout, but it really doesn't guarantee that the output or the callback is going to be executed right after the specified interval. It only executes when the stack is empty. So suppose we have multiple set timeout functions that had been there in the queue with same intervals. The event loop will only pick up one at a time, the first come first served basis. So it doesn't really guarantee that it executes right after the interval specified in the function. It is probably the next dish as close to as possible. Now, we sort of have a basic understanding of how event loop works on a high level. And before we come to how it sort of sits in Node, a bit about how traditional web applications work. So, for a long time, we had traditional web applications being developed in Spring, Java, and all that stuff. And one thing to be noted here was it all was multi-threaded. So every time we had a new request, we would have a thread spawned for it. The thread would process it, and it would give away the response. So it was multi-threaded in that sense. So each incoming connection was handed to a worker. The worker is now in use. It can handle no other connection, by the way. So there is a specified thread pool which you sometimes initialize your application with, and whenever there is more requests, it would sort of get queued. And whenever there is some sort of an IO operation which is happening, the thread would again be in a block condition. So just to give an example, this is a life cycle of a worker thread. So the thread could be doing anything, right? It could be reading a file, it could be sending an HTTP request, it could be doing an SQL query. So if you look at the life of a worker, most of the time it's actually waiting on an IO. So this is not a classic or a good use case of a thread, because most of the time, as you see, the thread is actually in a sleeping mode. It's waiting. It's not really being made use of. We're blocking wasted cycles of a CPU. And again, so when you take n workers, you can see how much of time is actually being wasted by the thread, because the thread is actually in a waiting mode for some sort of an IO operation. Uh, Now, sometimes it is even worse if all the threads are actually being in use and every incoming connection is blocked. So this causes massive traffic jams on high throughput applications. So is this the only way we can actually sort of handle concurrent applications? No. So that really takes us to how Node actually comes into picture here in the context of event loop. So Node is something similar to how we discussed in the JavaScript runtime, right? It's single-threaded, but not truly in that sense, because it is entirely a single-threaded in that sense. But whenever there's a new request that comes in, it passes the request to an event loop, and this event loop is actually what is making sure that all the I/O operations are executed using a C++ library, which is libuv, and then gives back the response, the callback, again to the event loop, and it executes. So your code actually goes to sleep, uses no system resources, will be notified via a callback when I/O is complete. So this is basically a picture of how it works. So unlike the other example where we saw a lot of time being wasted in the case of threading, here what happens is you have some request coming in, read file or some sort of an IO operation. It just passes this directly into the event loop, and it continues executing other stuffs. And then once you have the IO operations completed by the event, by the thread, it calls back the callback function again, and then it sort of at that point in time executes the callback function. So if you see, the time which is being actually wasted by the thread being idle is very less in a single threaded sort of model with the event loop in picture. So this is basically how it looks like. It's open to more work. Now, Node.js and EventLoop. Now we'll sort of put this up all together. So Node actually has four components basically. It has the V8, which is basically the runtime. It has the libuv, which is basically what the event loop is in the context of Node.js. It's basically a C++ library. So all the threading, all the IO operations are taken care of by by the libuv function. And we have the core functionality of Node, which is basically a bunch of Node modules. And finally, the Node bindings, which is written in C++, which actually connects everything together. So basically, the architecture would look like something like this. So we have the Node standard library, which is about 40%, which is in JavaScript. But the heart of Node.js, which is the event loop, the libuv, the V8, JavaScript runtime environment, and Node bindings, everything is actually in C++. So we'll now look at on a very high level how the single-threaded event loop model processing stuff works in Node. So we have multiple requests coming in from the client, and this is the event loop which is running, which is actually single-threaded as we discussed earlier. So every time there's a request that comes in, the request is actually passed on to the event queue immediately. So it can actually only handle one request at a time. So it just passes the request to event queue, and there is this event loop which is constantly looking into the event queue as well as the event queue, and then as in how there is a new request that comes in, the event loop looks whether it's IO operation or not, and if it's an IO operation, it sort of moves it to the thread pool, which is basically the libuv, where we have the multi-threading, the threads which take care of all the IO operations to be done. And then once the operations are done, it calls the associated callback, and then the response is returned to the client. So this brings to an interesting sort of discussion on concurrent versus parallel. So on a high level, we'll just try to understand what is concurrent and parallel. So concurrent is basically something where you have two threads running independent of each other. So the threads are making sure that both these executions are happening independent of each other. It could be in single core, it could be in multi-core, But if it's in a single core, it could be something like a preemptive multi-threading where the CPU actually executes one thread for some time and then switches to the other thread, and so thereby making sure that both the threads are being executed, and that's a single core preemptive multi-threading model. And in the parallel, we have two threads being executed simultaneously in all sense. So which is basically like when you have multi-core processors, we have true parallelism available, and so anything which is parallel is also concurrent in that sense. So talking about Node.js, whether it's parallel or concurrent, at a high level, Node falls in the category of concurrent computation, and this is basically the direct result of EventLoop, which is EventLoop as well as the Node single thread, because this being a single threaded event loop, which is basically the backbone of Node.js, handles more than one thing at a time, but at the same time it maintains a single thread. So in that sense, it is concurrent application. And if you were to achieve parallelism in Node.js, we would actually have to achieve it by starting multiple Node.js processes or child processes to occupy all processes in the case of multi-core CPU. With that, I'm done with the session. Thank you so much. Do you have any questions?
Yeah, one here.
Yeah.
So it's single threaded. What happens when the thread or process fails? Do you have to restart the entire?
Yeah, that's right.
The whole. If you have a Node.js server, there's only a single thread, and if that fails for some reason, you have to restart the entire server.
Yeah, that's right. But I guess that's the same with any sort of execution. Right? We have a single-threaded application.
Is there any implementation of Node or this kind of technology where you have multiple threads running?
Yeah, that's exactly what I had in my last point. So this is more like a concurrent execution, right? So in the sense like we have single thread in the front, but we do have libUV, which is basically what is the implementation of event loop inside Node.js, which has all the multi-threading everything, which takes care of the network operations or I/O operations like database operations and so on and so forth. So it is a classification like you have the single loop of node on the one side, and then it sort of pushes all the requests to an event queue, which is then given to the event loop, wherein all these threads are used to actually complete the task and call the callback. So if you were to actually parallelize it, you would actually have to start multiple processes of node instances.
So that's basically Node.exe multiple times.
Yeah, that's right.
Right.
Yeah.
Excuse me. In case of legal looping, in case if stack is not empty or not getting empty in whole application, then event loop will not be functioning as well, right? It will be in waiting mode.
Yeah, that's right. So yeah, that's an interesting point. Node is generally encouraged to be used when your use cases are like more like I/O operations, like DB calls or HTTP requests and so on and so forth. So you don't. It's generally not encouraged to use Node for developing computational intensive tasks in that sense, like image processing or something like that. So then the entire queue is actually the thread is actually blocked. It makes it really slow, so the incoming request sort of really doesn't get moved to the event queue. It sort of gets waiting there.
Excuse me. Let's say there are multiple users and you have a Node.js server running. So it is going to be a single thread for all the users together, right? Since it is in the server, it's a single thread for all the users. So when multiple users are making the request and occupying the call stack of the server, do you think it is efficient that rather in other languages you have one thread for every user, kind of parallel, but here every user, I guess it occupies single thread. Is it efficient?
Yeah, again, that comes back to the same point. Depends on what you're trying to do. So, again, in the context of this presentation, I said that there are few advantages for Node over the single-threaded sort of event loop model for Node over multi-threading. But there are situations where multi-threading are actually good. So when you have less resources to be shared, when you have the number of threads equal to the number of code, In that sort of situations, it's always good to actually go with, or when you're doing something which is very computationally intensive, it's always good to go with threaded sort of approach. But to also answer your question, as I mentioned, as soon as the request comes, it doesn't really process, it just moves it to the event queue. And so the event queue is then picked up by the event loop and moved to the event loop thread to the thread pool, right? So the single thread actually isn't really executing anything blocking in that sense. All it does is, as soon as the request comes, irrespective of whether it is blocking or not, it just moves to the event queue and so the event queue, and from there, whatever is blocking is actually picked up by the thread pool, and the other instructions get executed. So that makes it very fast. You don't really wait in that sense.
And one more question. To achieve parallelism Node.js, you said like we can couple more, one or more Node.js services.
Yeah.
I mean, how do we achieve that?
Uh, yeah, so I said like one instance is single threaded, right? You can actually have multiple instances, so you sort of scale it horizontally. If you have a single machine which is multi-core, you can have multiple instances. Like quad core, you can have 4 instances, scale up in that sense.
But how this request will be within each Node.js?
Yeah, then you have to have other sort of mechanism on top of it, like load balancing. You can use WebSockets to interchange messages across the instances.
And it is called as cluster concept.
Yeah, but again, depends on if it's that sort of a use case. If it's completely independent, you wouldn't want to do that. It's just to exploit the CPU to the maximum possible.
You cannot actually share state between two instances.
Yeah, yeah.
In case the multiple requests will be written on the node server, is there any crashes are there or otherwise it will be slowed down? Means,
Crashes.
crashes.
No, so that's what we have a bunch of use cases for which Node is generally encouraged to be used, like I/O operations and so on and so forth, which is basically like not so computation intensive. So I don't see any sort of possibility of it crashing or something like that.
In case of crashing, what we do? Actually restart the node thing like
Yeah,
that.
yeah, of course. It's like any other.
And I have another one doubt. Because of in case of crashing, we can identify with any event or anything else. For restarting that node automatically like that. Any other things coding or that.
Now the node model is available. And PM2, if you are hosting in the server, PM2 is there. That will help you automatically restart whenever the application is crashing. It automatically restart.
PM2 is.
PM2.
So those are additional things that you do on top of your server application. Any other questions?
Yeah, so LibUV, has it been used with any other technology apart from JavaScript?
Yeah, apart from Node.js.
Apart from Node.
Yeah, there are a bunch of applications of which they use. I'm not very sure about the name of the project, but Node is definitely a popular project where they use it.
But theoretically, it can be combined with any other program.
Yeah. It's an open source library and it's also being used with a lot of other applications. So it has a history to its own where it was another project, EV or something to begin with, and it was not compatible with all the OS, and then they made a lot of changes to it, and now it's adaptable to any sort of, like, it was with Windows, Mac, Unix.
Any more questions?
Thank you so much.
Thank you, Mithun. So we'll take a break for 15 minutes, then we'll come for the next